Hello, everyone, and welcome back. In the last session, we have discussed about ingress controller. So we can make use of the ingress when you want to open up the communication between the pods and the internet. So when we are working with ingress, it simply creates a single load balancer on port 80 or 443, and it makes use of host based routing to basically route the request to the pods, and path based routing to route the traffic to the pods. Now, in today's session, we are going to talk about two things: Minikube and kubectl. So we will look at how you can set up your Kubernetes cluster using Minikube, and then we will look at some hands-on with the kubectl as to how we can use this to interact with the cluster. Once again, before I start off with the session, please don't forget to hit that subscribe button. So grab your notebook and let's get started with this. So first, let's talk about Minikube. So Minikube is a lightweight Kubernetes implementation that you can run on your local machine. So if you want to run your Kubernetes cluster on your local machine, that's when we can make use of your Minikube. So this is ideal for developers and learners who are looking to explore Kubernetes without setting up a full-blown cluster. So if you don't want to create a multi-machine cluster and you're just looking to learn how your cluster works, that's where your Minikube can be really useful. So you can simply think of this as your personal and portable Kubernetes lab that you can use to run and validate your containers. All right. So Minikube was mainly designed to help developers test and deploy Kubernetes applications locally with very minimal effort. So this is basically running your Kubernetes cluster locally on your machine. And then you can use this to test out your applications to see how it would run when you actually run them in your production clusters. Now, let's talk about some of the features of the Minikube and what makes Minikube the go-to choice. So the first feature we have is the multi-node cluster support. So using Minikube, you can test out your applications to check how the applications would perform in an actual environment. The next feature we have is the add-ons support. So you can easily enable tools like metric server, Helm charts, and ingress by making use of the add-ons. The next feature we have is support for multi-container runtimes. So you can use Docker, CRIO, or Containerd as your runtime for running your Minikube. And the last feature we have is the cross-platform compatibility. So you can run Minikube anywhere you want. You can run it on Windows machine, Mac OS, or Linux platform. So you can choose the platform that you want. Now, let's talk about why should you use Minikube. So first reason is learning Kubernetes. So Minikube is simply perfect for beginners who are looking to experiment and practice the commands locally. So if you're mainly looking at practicing your Kubernetes without setting up an actual cluster, that's where you can make use of your Minikube. Then we have the application development. So using Minikube, we can quickly test our applications locally before we start deploying them those applications in the production cluster. So basically validating the applications. And then finally we have the debugging. So we can easily troubleshoot any Kubernetes configurations in a safe and local environment. So we don't have to do anything on the production cluster. We can do it using Minikube on your local machine itself. So Minikube is really a fantastic tool for developers working on laptops or in environments without access to a full Kubernetes cluster. Now let's move on and let's get our hands dirty. So we will look at how you can set up your Minikube. So here I have the instructions. I'll share the link to this. I also have these instructions in my GitHub repo. I will share the link to this as well. But before you can start off with the Minikube setup, there are some system requirements that you will need to satisfy. So you will need a minimum of 2 CPU core, a minimum of 2 GB RAM, 20 GB hard disk, internet connection, and a container runtime. So in our case, I will be using an EC2 instance, and I will be using t2.medium because that is what will satisfy this requirement for me. And please remember that you'll have to pay money for this. T2.medium is not free. So here I have an instance running, and you can say I'm running t2.medium because this is what gives me the 2 CPU core and 2 GB RAM, which is the minimum system requirement for setting up our Minikube. And as per the instructions, you'll also need to install a container runtime. So in our case, so you can use Docker, Hyper-V, Podman, VirtualBox, any of these options. So in our case, we'll be using Docker. So before we can install Minikube, we will need to install Docker on our machine. So let me quickly log into this EC2 instance here. So here I have my EC2 instance. So the first thing we will do is we will update the machine. So we'll use sudo apt update. So this will go ahead and apply any updates that are available for this Ubuntu EC2 machine. And post that, we will be installing our Docker. So Docker is going to be our container runtime, or the virtualization that we will be using to set up our cluster using the Minikube. So let's just wait for this to complete, and that is done. So next I'm going to install Docker. So this is the command sudo apt install docker.io-y, and this should go ahead and install the Docker for me. Now, like I said already, all the instructions are available over here. So if you want to just copy this over, you can do that as well. So here my Docker is installed, and we should be able to validate that. And let's quickly check the service. So sudo service Docker status, and my Docker should be run. So this is going to be our container runtime. Step 2 would be to download the Minikube. So like I said, here is the official page from where you can download and set up your Minikube. I'll provide the link to this in the description section, so you can just go ahead and follow this instruction. So here you can see the system requirements and the installation. So we're looking at Linux, architecture, stable, and then Debian. So Ubuntu will be your Debian. So first we will be downloading the package. So let's download that, and once that is done, we will be installing it using the second command, which is this one. So let's run these two commands, and this will go ahead and install Minikube for me. And the last thing that we have to do is start the Minikube, and the command for that would be here you can see this will be the command. So Minikube start -- driver docker. So we will need to tell which container runtime we want to use, or the virtualization that we want to use to start our Minikube. So let me take that, and we will run that over here. And you may get this error, the permission denied error, for your Docker socket. So one way to fix this would be to run this chmod command. So sudo chmod 777. So we are basically giving full permission to it. So I'm missing a slash, and then let's try this once again. So this will start setting up the Minikube for me. I will add this instruction, this particular command in the instruction as well, so that you don't miss it. But basically you can see here we are getting a permission denied. So that should fix the problem, and this will start setting up the Minikube cluster for us. All right. So this will take a few seconds. So give it a few seconds, and that should set up the cluster for us. Okay, so now my cluster is set up. So this is basically the output, and I should be able to, so you can see Minikube should be ready for me to use, right? So I can see everything. So get the status of the local cluster. So let's quickly look at this. So we will run Minikube status, and sorry, I have a typo, so let me correct that. Yeah, so you can see that's a control plane. My host is running, Kubernetes is running, API server is running, the kubeconfig is configured. So basically all the components, right? So that's basically what your Minikube is. So like I said, Minikube can be used to set up a Kubernetes cluster on the local machine. And that's it. Now we have set up a single node Kubernetes cluster, and this is now running locally. I mean, I'm running it on an EC2 instance, but you can run it locally as well. So that's about your Minikube. Next, we are going to talk about kubectl. So we have set up our single node cluster. Now, how do we interact with this cluster? How do you create resources in this cluster, be it your deployments or pods or anything that you want to create within this cluster? How do we do that? And this is exactly where your kubectl comes in. So kubectl is a command line tool that we can use for the day-to-day management of our Kubernetes cluster. So by using this tool, we can create new resources within the cluster. So resources can be your pods, your deployments, updating the resources, deleting the resources, getting the information about the resources that are running within the cluster. All those things can be done by making use of your kubectl. So we are going to deep dive into this, and by the end of this video you will have better understanding of how kubectl works under the hood and have enough knowledge to start testing out some of the simpler commands within the cluster. And we will be running the commands within the Minikube that we have set up. Currently we do not have any pods running here, and we will look at some of the commands that you can get familiar with using kubectl by creating a couple of pods. We'll also look at the replica sets because this is a great way to show Kubernetes working in action. But before we go there, let's understand how this actually works. So to create the resources within the cluster, we will be creating something known as a manifest file. Now, manifest file is basically your instruction file. So basically the kind of resources that you wanna create, and you can write this file either in the JSON or you can write it in the YAML. So whatever you're comfortable with, and we simply describe the resources that you want to create, like you want to create a pod, or you want to create a service, or you want to create a deployment. So anything that you want to create, we define that within the manifest file. Now we will explore the components of the manifest file shortly, but for now let's look at how the manifest file is used by kubectl to create the resources. So let's say when we run an example of create command. So let's say here I will run this command kubectl create -f, and then let's say manifest dot YAML. So basically I want to create the resources that are defined within this YAML file. Now what happens here is the kubectl utility will convert this manifest file into a JSON payload. All right, so the kubectl will basically convert the instructions that we have written within this manifest file into a JSON payload, and then this will send it as a REST request. All right, and this request will go to your API server. So API server is the one that will actually perform the action for you, and this will be sent over HTTPS. So once again, we will create the manifest file, and then when we run your kubectl command, which in this case would be, let's say, create, what the kubectl will do is it will convert this manifest file into your JSON payload, and then it will send it as a REST request to the API server over HTTPS, which will basically process the request for us. So kubectl basically will send the request to the API server, and then API server will basically execute it for us. So that's basically how your manifest files work, and this is where kubectl can be used when you want to interact with the cluster. Now let's look at an example of a manifest file. So your manifest file consists of a number of key value pairs. So here you can see the API version in this case would be the key, v1 would be the value. Likewise, you'll have lots of key value pairs. So manifest file consists of a number of key value pairs. So there will be a key and a value associated with it. So in this case, first we have declared the API version and that we want to use. Then we have declared the kind, and the kind refers to the resource or the component that we want to create within the cluster. So here pod is one that we are using right now. So note the capital letter here, and this is referring to Kubernetes component, and so syntax is very important over here. So you can see the pod here, I'm using the uppercase P, so that's very important. Then we have the name, which refers to a unique identifier for the pod. Then we have the spec section where we have defined the parameters like which container image to use, what port numbers we want to use for the communication, and then so on. Alright, so this is an example of your manifest file, basically the instructions for the resources that you want to create. So let's run the command and let's see how this actually works in action. Now, before we can run this command, we are yet to install our kubectl, right? So let's see how we can install the kubectl tool. Once again, I have the instructions in my GitHub repo to set up your kubectl. So I will share the link to this in the description section. I will also share the link to the official documentation from where you can find the instructions if you're interested. But essentially, we will need to download the kubectl binary files first. Post that, we will be installing the tool, the kubectl tool, and then finally we can validate whether my kubectl is installed or not, right? So pretty much very straightforward, nothing fancy. It's just 3 instructions and my kubectl should be ready to go. So now the first thing we will do is run this command kubectl get pods. Alright, so this command is going to see if there are any pods currently running within our cluster, and as you can see here, there are currently no resources that are running in the cluster. So now let's take a look at the manifest file that we are going to use. Alright, so we have all the instructions to create our pod. So here again within this repo, this is the example that we are going to use, and I'll share the link to this. I'll share the link to the repo itself so you can use that. So let me create a file over here and let's call this as pod.yaml. And so basically we are creating a pod, we are giving it a name, we are giving which image we want to use, and the port mapping. So basically all the information, right? So this is the same file that I explained a little while ago. So using this file, we will be creating our pod. Now, to create these resources from the manifest file, we will use this kubectl create command, and then we will use this -f flag, and this says that we want to pass the file name, which is the pod.yaml in this case, to create the resources. Now, when I run this command, this will go ahead and create a pod for us, right? So we can see that our nginx pod has been created, and now if I run the kubectl get pods once again, I should be able to see my pod running over here. To get some more information about our pods, we are going to use another command, which is kubectl describe pod and then the name of the pod, and we are going to see a lot of detailed information. We don't need to go through all of this right now, but just a few things. So you should be able to see the image that we are using, the port mapping, the status, when this was started, so some of the details, right? But there are more information, but we're not going to go through all of them right now. So our pod is up and running. Now let's look at another manifest file here. So this is the another manifest file we are going to use. So let me copy that and let me create one more file over here. So here I have the manifest file for our replica set. So here you can say I've defined replicas as 4. That means I'm telling that I want to run 4 copies of my container image. So essentially what's going to happen here is it is going to look at Docker Hub, which is our Docker registry where this container image will be available, and then pull the latest nginx image for us. We have not really declared any specific version, so this will always pull the latest one from the registry. So let's take this and so here I have the instructions, and let's create this. So again, for this we will be using the kubectl create command. So kubectl create -f and then the file name, and this will go ahead and create a replica set for me. And now if we run this kubectl get replica set, I should be able to see my replica set. So you can see here the desired count was 4. Currently there are 4 containers running, of pods running, and then all the 4 pods are ready to use. Now if I run the get pod command, you will see that I will have 5 pods running, right? So the first pod was from this file, and then the rest 4 of the pods are coming from the replica sets. So we have the Nginx demo, one that we created earlier, and then 4 pods that we have created using the replica set. Now note the naming convention for the replica set, followed by some randomly generated letters and numbers that makes up the unique identifier for the name. Just to show you that if I use the kubectl delete pod and then pass through one of the pod name, it is going to delete the pod. So let's say we will delete one of the pod from the replica set. All right, so let me copy this, and we will say kubectl delete pod and then the pod name. So this will go ahead and delete the pod for me. And now if I run this kubectl get pods once again, you can see that I still have 4 pods running, right? But you can see the timestamp over here. So this was created 8 seconds. So basically I deleted a pod, but because I deleted a pod from the replica set and I have defined that I need 4 pods running at any point, replica set went ahead and created a new pod for me. Now let's try deleting this particular pod. So let's say kubectl delete pod and then the pod name. And now if I do a get pods, you will see that I have 4 pods only. So this is because this is a standalone pod. It does not belong to the replica set. We have not defined any count for this, so this is not really highly available. So if I delete the pod will be gone, right? So this is because there is nothing to automatically generate the pod for us. So there's lots and lots of commands that we could look at, and for the moment I'm just going to stop here. So kubectl is a great tool and definitely want to get hands-on using it. If you want to look at doing something like certified Kubernetes administrator, this is something that you have to get very comfortable with. But just to help you start to understand the fact that ultimately what we are dealing with are resources that have been declared, and using these manifest files, we're able to quickly use the kubectl command line tool to interact with the API server and add resources and remove them. That's all I have for this session. If you found this video helpful, please give it a like, share, and subscribe to the channel for more content on AWS EKS. Hit that bell icon to get notified when I upload new contents. Please share your feedback or any queries in the comment section below. Thank you for watching, and I will see you in the next video.